Video, I'm going to show you how to work a class assignment that talks about an introduction to R. You can find this assignment on our website, and it will have you test some of the more basic functions in R, and then get into a little bit of the statistical uses for R. And this is for my structural equation modeling class, assuming that no one has had R before. Okay, so the first thing it asks you to do is to create an R script file. So I'm going to do all of this work in, make this a little bigger here. I'm going to do all of this in RStudio, which is a really great program that lets you manipulate R and also see kind of what's going on. Alright, so our first goal is to create a script file. Well, that's fairly easy to do. So this is RStudio, and I don't have any scripts open at the moment. So what I'm going to do is click on the little plus sign here for new, and then our script, and then I would save this to continue to use the file later. Okay, so I can save this current document. It's going to ask me where I want it to go. So let's put this in a new shiny folder. Okay, I'm going to call this intro R. Okay, now the extension for a script file is .r. And that helps it know that this is a script file and not data or Word document, that sort of thing. So first step done. I now have an R script file, and it's called intro to R, and you can see the name of it right here at the top. What's our second step? So the next thing I need to do is make a vector of numbers. And so we're going to do a couple of these at once. Cool thing is that we can cut and paste some of this stuff into our script file now that we have it. It's going to be a little cranky with me because this is not technically code for R, so that's what the little X symbol over here is. Like, I don't know what to do with this thing because it's not R code. So let me use a comment symbol to get it to go away. Right, and I can make all this a little bigger so you can see it. Alright, so let's make a vector of numbers. And I'm going to use the repeat or sequence function. So I'm going to call my vector of numbers, numbers. And let's start with repeat. Okay. So the way repeat works is it allows you to repeat a specific number a certain number of times. So you tell it to repeat. I want to repeat 1, let's say 4 times. Okay. So it is the thing you want to repeat, so that could be a whole sequence of numbers that I want to repeat, or just the number 1, and then the number of times you want to repeat it. So it's going to make me a vector, so I'm going to run this. And to run it, I'm on a Mac, so I'm going to hit Command and Return. If you're on Windows, you can do Control R or Control and Enter, or I can click Run right here. So what that did was it created me a vector of numbers 1, 1, 1, 1, because I told it to repeat 4 times. Other thing I could do is use the sequence function. Oops. So the sequence function works where you have to have 3 arguments. So the first argument is where you want to start. So let's say I want to start at the number 1. The second argument is how far do you want to go. Let's say I want to go to 20. And then the last argument is by what number. So let's go up by a half each time. So I should get 1, 1.5, 2, 2.5, etc. So let's run that. And so if I look over here in my environment window, I can see that I have numbers 1 through 20, and it repeats by half. If I'm not sure because I can't see the whole thing over here, I can type numbers down here in the command window. And now I can see all of the numbers in there. So 1 through 20, and it's going up by halves. All right, the other way you can create a sequence of numbers, so we did that thing here, is by using a concatenate or including a colon. So let's do the concatenate first. So the C command is for concatenate, which is way too hard to spell, so let's say combine, and it will combine all the things that you include in the C as one vector. So C is for vectors, so one row of data essentially is a good way to think about it. And then when you get into working with matrices and data frames, you'll use rbind for rows and cbind for columns. So remember, C is just for one group of data, one vector, one row. So let's say I want to combine 1, 2, 3, 4, 5. That's not the most efficient way to do it, but I can do that. So I have numbers 1, 2, 3, 4, 5. The other thing you can do that's even simpler than everything we've done so far is just do numbers as 1 colon 5. Now that will give you a sequence of numbers 1 through 5. So if I look over here, and those count up by 1. So using the colon symbol always increases by 1. All right, so we've made our vector of numbers. The next thing is to use the length function. Now length is an interesting function because it doesn't always do what you expect it to do, but for vectors it's really easy. It tells you how many things are in that vector. So I would just type length and then pick one for whichever one I want to use. So numbers, let's use the first one. If I run it, it tells me that that length is 4. I could save that as another number, so I could say x equals length. But the interesting thing about length is if we were to use length on, let's say, a matrix or a list or data frame, it doesn't give you the number of rows, it actually tells you the number of columns. So you have to be careful with the length function. It doesn't always do quite what you expect. Okay. All right, so we did that. Let's do a matrix now. So the matrix command allows you to create a matrix which is got rows and columns and save it, but it doesn't always do this in a way you would expect. That's the interesting thing about R. Whoops. Sure, why not? Okay. I downloaded a new version of Studio and it's still working out its kinks, I think. So let's save this matrix as max. Oh no, max is a function. Let's not do that. My matrix, if you will. Okay, so I'm going to do matrix. If I remember the code correctly, I think it's matrix. If you can't remember, what you can do is in the bottom, you can do question mark and then type in the code that you can't remember. So I typed in matrix and it lets me go, oh look, here's how to create a matrix. So the first thing I want to do is say what my data is. So that's what it says, data equals NA. So tell it what kind of data you want to use. If I have a 5 by 5, I need at least 25 numbers. So I'm going to go 1 through 25. Then the things you have to have is number of rows and number of columns. So I'm going to say 5 and 5. So let's run that real quick, see what happens. So now I have this matrix over here under data, and so it's clickable, so let's click on it. And it pulls up the matrix over here, which is the same thing as the view command. The view command is one of the few that actually starts with a capital letter. So make sure if you type in view, it needs to have a capital V. And it filled in, not what you would have expected, it fills in going down and not across. If you wanted to change that behavior, what you could do is this by row equals true. Okay, so it's over here in this section where it says by row equals false. And so what that means is I want to fill in going across and not down. So let's run that again. Now let's look at matrix now. So now it's filled in going across. I think most of us think about this in a researcher's point of view as data per participant. And so I'm thinking about each participant one at a time, and they're usually listed by rows, or each piece of data from a participant. And so you might want to use the by row equals true if you use a matrix. We won't always use matrices because data frames are more useful, but it has that same kind of pattern of code. Okay, so the next thing to do is to pull out row 2, column 3 from the matrix. Okay, so this is kind of getting into subsetting. Subsetting is very important for lots of statistical tests and being able to understand how to get values out of data so that you can look for missing values, you can look for out of range variables, that sort of thing. So first thing you have to do is say, okay, I want to use my matrix here. Now anytime you have, you're trying to pull out values, you're going to use square brackets. And that is saying look for this thing in the data frame or the matrix. Okay, so square brackets indicate look for something within this variable, whereas parentheses are usually used specific for functions. So that's do this thing. So do an average or do a standard deviation, whereas this is look for. So let's say I want row 2, column 3. Well, the way that data frames and matrices and vectors are listed, not vectors, sorry, data frames and matrices is row, column, comma, column. So here I would do 2, comma 3, because that indicates I want row 2, column 3. So before I even do that, let's look at my matrix. I'm going to go down to row 2, column 3. I should get an 8. Okay, so that's the good part about working with small variables when you're trying to learn, is that you can check yourself. Is this the number I would have expected? Okay, so row 2, column 3 would be an 8. So if I do 2, comma 3, let's see what it gives us. And it gave me an 8 down here in the command window, okay, in the console window. If I had done the reverse and done 3, comma 2, it would have given me 12, because it's thinking row 3, column 2 is 12 here. Okay. So you want to make sure you understand how to pull out rows and columns. So when you're doing a command for data frames and matrices, it's row, comma, column. If you don't include the comma, it will have a fit at you. So let's say I tried to do, should have picked something easier to type here, my matrix, and I just said, give me 2. When I run that, it gave me a 6. So what does that even mean? Well, it gave me 2, and then it assumed that I meant column 1. Okay. A lot of times it will tell you that you don't have enough arguments, because it's expecting rows and columns. Okay, so we did this line. Now for something completely different, data sets. Okay. Now, base R comes with a bunch of data sets, but you don't realize that they're there because they're sort of hidden from you. So you can use them at any time if you know their names, but you don't always see them here in the environment window. So this is a global environment. These are the things that I have put in, but there are package environments. And so the datasets package has all of these different datasets in it, because that's the point. And so you just don't always know that they're there, because generally we're looking at what have we typed in. Okay. So that's the first thing, is that the USARS is a dataset saved in base R, so everyone has it. Okay. So what I could do is type data USARS and tell it to load. And so what that does is under values it says promise. That means I know it's there, but I don't want to show you what all the columns and rows are right now. I'm just kind of holding it like, oh, okay, you're going to use this. Okay. The head function is really useful when you have a large data set. Let's use that one. Okay. And it allows you to see the first 6 rows of a data set. So let's run that. So that USARS has murder, assault, urban population, and rape in it. You'll notice when I did that, it popped up over here and became data that I'm currently using. And I could use a drop-down window to see those exact same things. Okay. And so the interesting thing is that now that I've used it for something, I've looked at it, it's popped up and now is part of my current environment. Okay. So the head function will let you look at the first 6 rows of any data set. The next thing it asks you to do is calculate a summary of USARS. Well, that's easy. Just type summary. Summary is an interesting function because it depends on what you're trying to calculate a summary on. If you're calculating a summary on a data frame or a matrix, it's going to give you a set of values for each column. So let's do that. So USARS. All right. So what did that do for us? Well, if I look down here, for each column, murder, assault, urban population, and rape, it gave me min, max, quartiles, the median, and the mean. The only thing I don't love about summary is there's no standard deviation, so that you would calculate separately. But it gave me just a general kind of like, here's what's happening in each column. Summary does frequency tables for factor columns, so it's a really flexible function. Now, if you run summary on a list, what which is like, let's say you save the results of a regression and you run the summary on that, you're going to get a specific set of output that's for regression. If you run summary on ANOVA, you're going to get something different. So summary is a really neat function because it does different things for different saved variables. And so you kind of have to get used to it. It doesn't always give you the average. Sometimes it gives you output that you might expect from like Spss or Excel, that sort of thing. All right, so I'm out of things to do. Let me go back to my assignment here and look at what else we've got. So let's copy all this stuff and start working on that. All right, so the next thing that you can do is import a data set. There are lots of ways to import a data set. I'm going to show you probably the easiest one. So one thing we've already done is imported data from base R. So we moved a data set from being sort of usable to being used, and that's why it's up here in the data frame, the global environment for me. But let's say you have your own data and you want to import it. So what we're going to do in this particular video is talk about how to import CSV files. Those are probably the easiest thing to work with. If you want to watch some of the other Intro to R, like lecture style videos, it also talks about how to import SPSS files and text files. All right, so what you can do is it's the read.csv function. Now, I can never remember all the commands for that, so I always do this the easy way. So click Import Data Set over here in the Environment window, and then from text file. It's going to ask me to find where my file is saved. I haven't set my working directory, that's why it doesn't quite know where to look. Right. And so I've got this text file, intro R CSV. It is a huge file with 33,000 lines. Okay, that's not huge, but it's a big file if you're used to working with participant data where you have 100 lines. And I wanted to use a file that was so long that you couldn't see everything so that you could get used to working with big data sets. So let's hit open. And what that does is it brings you to a window that shows you what's in the data set. And if you get a bunch of scribbles over here, that usually means that you're trying to open a Word doc, you're trying to open a .r file this way, which is not a data set, that's a script, or you're trying to open something you can't figure out. So first thing I'm going to do is I'm going to rename this something I can type a little better, like data. Okay, you really want to be descriptive with your names because that'll help you when you're working on a statistical analysis, but right now I'm just going to call it data. Make sure the heading thing is clicked yes if you have a row that's headers. So if I had clicked no, it would name everything variable 1, 2, 3, 4, and then it would be really unhappy with me because everything would be a character code because I've got text here. So I'm going to click yes. And then there are a lot of other things that you can change, but this data looks like what I would expect, so I'm just going to hit import. So what that's going to do is automatically create me some code down here. It says data equals. I'm going to copy that, stick it here. So that's a quick and dirty way to get it to give you the read.csv data information. It also gives me the path for this specific file. I don't want to move the file or this line won't work anymore, but I can always re-import it. This is where working directories would be really useful. And cover that more in our lecture videos, but that imported the data set. The other thing it did was it opened it for me and it showed it to me, but again, it is such a huge file, 34,000 lines, that I don't know that I want to scroll through everything and look at it. So I'm going to close this. The other thing it does is it pulls it up here in the global environment, calls it data. It tells me how many observations there are, that's how many rows, of 14 variables, that's how many columns. So even over here, it tells you rows and columns in order. The other thing it does is it lets me expand it and look at what everything is named. Okay, so these are all the columns in data. I could also use the head function to look at the columns, the first 6 rows of each one, and then I could use the ls function to just give me a list of all of the column names. Now, the thing about the ls function you gotta be careful with is it gives you a list of all the column names in alphabetical order. So those are not the order they go in. So it's not errors column 1. The first column is actually experiment number. Okay, so it gives you all the column names, which is really handy if you can't remember how something is spelled, but they're not in order. So be sure when you're calling them or you're using them, you use their real name and not the column number to subset for them. Alright, so the next thing I want to do is recode this which hand column, and this one was a little more trickier than I had intended it to be, so let me show you what's going on. So if I tell it to show me a, let's do summary of the which hand column. So instead of doing summary of the entire data, I'm going to do of the specific column called which hand. So I'm going to use the $sign operator. And here's the problem. For this which hand variable, I have 60 of them that are in A, so that's why it's blank. A whole bunch with left in lowercase, another whole bunch with left in uppercase, and look at all the different ways that right is spelled. Okay, and then one person who typed right and left, so I don't know what to do with them. And then there's a bunch of different codes for this, which is bad. I don't want it to have that many different levels. It needs to be left, right, or blank. Okay, and if I look over here at what type of variable which hand is, it's a factor with 12 levels. It should basically be 2, right? Left and right, and maybe ambidextrous, and then nothing else. And so you're a bunch of different recode functions. There's a recode function in cars, or maybe the psych package, I believe. But we can do this sort of manually in R by using subsetting. And so what you want to do is you want to find the spots where things are coded incorrectly. So let's start with looking for, in our data set, we're going to use rows and columns here. And so this is the tricky part. I want to look in each row for which hand. Okay, so I'm going to type this in the row spot, which is the first spot. And I want to look for which hand. Okay, so I want to, in each row, only in this specific column. So I'm looking by row because it's written first in that column. I want to find things that are equal to one of these bad spellings. Now you can't just say equals, because equals is reserved for setting something equal to something. So if you say x equals 4, you're saying now keep a variable named x with the number 4 in it. And so what you want to do for a logical operator or checking for something, you use equal equal. If you've ever done any programming before, that wouldn't be a surprise to you. But don't just say equals, because it won't like that very much. What you want to do is say, I want to find in rows, in this particular column, where are things equal to what? Now I've created a summary down here so I can look for, let's say, everything that's in lowercase left. So that will give me, if I just run this, what it'll do is actually give me everything that's coded as left. Okay. And it's huge, it's huge, it's huge, but you get the idea. Here's everything that's coded left. The real problem with this code is that it also, oops, head is a lowercase, gives you things that are coded as NA. Okay. So I'll show you what we originally thought you should do. And then talk about the way to fix your problem, your error message that you're going to get. So the first thing, I can subset the data out where everything is left particular. So that'll give me all rows and all the columns that have left. I mean, look at the way the head function worked. It gave me all the rows with left and all the columns. Well, I don't want to fix every single column. I want to fix the column that has these particular problems only. So what you want to do is say, I only want to fix the problems in this column. Okay? And so your two column names should match if this is what you're trying to do. Essentially, this would be an accuracy fix issue. Okay? So everything in this, I want to look for by row everyone who's a lefty in that column, and I only want to fix them in that column because otherwise it's going to set every row, every column to the word left. Now what I want to do with that is set every person who's coded as lowercase left in the which hand column. I actually want to set that code to everything in uppercase left. And what this whole code is going to do, it looks kind of hairy, but really what it does is it finds everybody who's coded as left, takes that particular column, which hand, and then codes everybody now to uppercase left. Okay. All right, if you do that, you get this fancy error message, or a warning message, I guess. And it's a whole bunch of scribble, and you go invalid factor level, NAs generated. So it didn't like me doing that because two reasons. The first, really, the biggest issue is that there are NAs saved here. So let me show you. Let's say we set some data to cheese, and I want to find this particular set of data. So I'm just going to look for where people are left in this particular column. So I've saved the data that I have. And now I want to see a summary of what that data is. Right? And so what it does is it showed me, look at all these NAs. And that might be because it freaked out on me a minute ago, so I can reload my data set here in a second. Let's try that first. So I'll reload the data. And then let's see what cheese looks like now. Show me a summary of cheese. All right. So, yeah, that's because I freaked it out by trying to run this code. Look at what happened. It gave me everybody that had a lowercase left. That's what I would expect, right? But when I tried to run this, and you look up here the first time I ran it, it gave me a whole bunch of NAs. Look at all those NAs. So it could be because we have NAs in the data set, or it could be because this thing came in as a factor. Okay, so if I look over here, the type of data which hand came in. It came in as a factor variable, which means that it's recoded everything in the background with these specific codes where lowercase left is 1 and uppercase left is 2. So let's try instead keeping with a code that is already saved in the factor variable. So I know capital uppercase left is a code that is there, so let me try doing that instead. And that seemed to have worked. It didn't give me an error message. And so let's see what's happened now. Let's just look at the which hand column. Oops. Now, all of the original codes that were lowercase left became codes that were uppercase left. And so what I would have to do is recode them one at a time. So you'd have to know all the different spellings. Now, that being said, it's much easier to open the CSV file in Excel, change them all to what you want them to be, and then import the data, but this is how you do it if you didn't want to do that. If you knew you were going to have to import this data continuously, like once every couple months, I would tell you to code it in R, so you could just run this code once every single time instead of opening Excel and closing Excel a bunch of times. The other issue is, like, let's say you actually did want it to be an uppercase left. Well, right now, that's not something you can do because of that issue with it being coded as all these different factors. Okay. So what you could do is change the which hand column to a non-factor variable, like leave it as a character. So let's do that. I want to take the which hand column and I want to do as dot character. Okay, so make it a character file instead of a factor, because I can always switch it back later. And I want to say that particular column, go. So if I look over here, now my which hand column is a character file. Let's take a summary of that. Oops, gotta tell it where it's at. Okay. And now when I take a summary of it, it just tells me that it's a character file. Cool. What you'd want to do instead to see it is the table function. Table function will give you a frequency table. Alright, now I have the same data, but it's set to characters, so that means I can manipulate it a little easier than trying to set it with factors. Now let's try this again, but I don't have any lefties here. Now let's try making everything uppercase. Like I, for some reason, need it all to be uppercase. And then so what that did was now fix my problem. of it all being lowercase. And so now everything is coded as uppercase left, and I could go through and fix all the right problems. And then what I would do is I could switch it back to a factor level. Now, if you're having trouble where it gives you a warning message of this sort of warning, NAs generated, I was having trouble getting it to do this for me because it kept trying to change the NAs as well. You can tell it to omit the NAs while you're working with it. So you would do this exact same line, because this was an error message we were getting in class. You could do na.omit. And that will temporarily ignore all the NAs. It won't delete them completely from your data set, which is what it would normally do. But because I'm doing it only during this logical operator, it will delete them while it's analyzing for that particular code. And so that'll help you sort of clear out the NAs for a second to fix all of your other problems. All right, so that is a very long description of how you might recode variables using subsetting. Now, let's create a summary of the data set. So I can just do summary of my data here. Right, and it looks a little nutty, but that gave me a bunch of different codes. So it told me now when you have a factor variable, you can see that it gives you a little mini frequency table. For all of my variables that were numbers, it gave me, let's see if we do that. There we go. Now it's all lined up. For all my variables that were numbers, it gave me min and max. For everything that came through as a factor, it gave me a little frequency table. But because which hand is not labeled as a factor, it just says character. So it doesn't really do summaries on characters. Table function works great on characters. And that'll give you a frequency table. All right, so I did that. Now, if I want to permanently exclude the NA values from my data set, what I can use is na.omit, the same one. So let me call this something like no missing. Okay. So I do na.omit on the data. Okay, so that is going to omit all of the NA values on the data. So let's watch that happen here. I've got 33, almost 34,000 lines. If I run this code, I get a new data set called no missing, which is a useful name. And now I've lost 35 participants. So it deleted 35 rows that has some sort of NA in any column. So the good thing about NA omit is it's really quick. It will delete anybody who has any missing data. The bad thing about NA omit is that you can't be specific to a column. You have to do that a little fancier. But if you're trying to look at, okay, only exclude people that have an NA in this column, you could use the subsetting rules described above. All right, so if I wanted to create a data set with left-handed participants only, I could do subsetting like we were doing up here. So give me all the rows with only lefties. But let me show you another cool command, which is subset. So there are a bunch of ways to do the same thing. So the subset function is a little easier sometimes to use. So let's create a data set, so lefties, and I want to subset that data. So the way subset works is you use a data set and then you create a rule. So what's the rule? I want my which hand column to be equal to left. I think it's all uppercase at this point. And then the next thing you can do is tell it what you want to keep. So I could select only specific columns. I could tell it just pick this particular, columns 1 through 3, but I want to keep everything, so I'm actually going to leave it blank. And this will let me pick all the rows that have left as their marker for which hand. So my new data set only has 3,000 rows in it, almost 4,000 rows in it, because there aren't that many lefties in this data set. So it's a good 10% of the data, which makes sense. And that is another way to do a subset. It also would have worked to do data where, oops, sorry, we're working with no missing. No missing data set where the no missing column and which hand is equal to left. Okay. but then I would tell it to give me all columns. So find all the rows where somebody scores left, and then give me all columns. And let's make sure those work the same. Okay. So lefties 2 gives me the exact same data set. So 3,050 people. Okay. Same ways, there's 2 different ways to do the same thing. Okay. I like subset a little better because it seems obvious what you're doing, but knowing how to do that with the matrix code is also very important for getting how to pull out data in, like, say, a regression. All right, so the next thing down is going to be correlation tables. Okay. And so I want to create a correlation table of these specific variables. So back to subsetting, if you're not tired of it yet. Okay. So the code for correlation is core. And so let's look at what core requires. So I'm going to type core down here. And it tells me down here what core is. So core is the standardized version, cov is covariance tables, var is variance tables. And so it says X, well, that's not very helpful. It says a numeric vector, matrix, or data frame. So these are what are all the columns that we need. You can run core on 2 columns, X, comma, Y, if they're just 2 different vectors, but I have a bunch of them, so I want to make this all into one matrix or data frame. And then the important thing here is the use function. So one thing to notice is the way that each data set, each function handles NAs is different, which is exciting at best sometimes. So it can be kind of frustrating. So if you look at variance here, it uses the na.rm. So it says, what do I do with NAs? So I think about it as remove NAs, question mark. And so you can set that to true or false. In these cov and core ones, though, it uses this use command. And the use command here has different options. Everything would be all rows and columns. All observations, the same thing. Complete observations would delete everybody list-wise. na.or complete. And then the one we're going to use is Pairwise Complete. So Pairwise Complete matches what Excel and SPSS will do for you when they create correlation tables. It'll only ignore people who have NAs when they are being used in that specific calculation. Okay. So let's try that. Now, I want to use all of these particular columns. And so I want to create a little vector. So remember, that's the C command of these rows and of these columns specifically. Now the cool thing is if you're cutting and pasting column names, like let's say from the list function, it'll already have the quotes around them. But if you don't, and you're using RStudio, you can highlight the word you're looking for, hit the little quotes button, and it'll put the quotes around it. Super nice and handy. So I want to create that. The first one here. Let me do the second one. So I'm just taking my Microsoft Word code here, or Microsoft Word cut and paste, and I'm just kind of editing it to be in R code. Right. All right, so what that'll do is it'll give me, I just only want to use those particular columns. But if I just tried to tell it use these columns, it wouldn't know what data set to pull them from. So we're going to use the lefties, data set, if I can spell today. And I want to use all rows, so I'm going to leave the row part blank. Spacing doesn't matter, it just helps you to see it, I think. I want to use all rows and these particular columns. Okay, so now we've kind of done the reverse of what we have been doing before. We were talking about look in rows, give me all columns. On this particular one, I want to say use all of the rows, but only these columns. And so that's how I would subset this data set. So I'm going to stick that in my first area here, so for under core. So that is just the data set part. So that's X here under core. I don't need a Y because I have all the columns I'm going to use. So Y is only if you're doing two vectors. And then the next thing I want to do is tell it what to do for NAs. Okay. Actually, let's not do that first. So let's run this thing and show you what happens if you have NAs. I take out this comma or it's going to get mad at me. Unexpected input. So it didn't like something that I was doing. Okay. So covariance. Let's try it without the spacing. That doesn't normally matter. To make sure I have everything in the right place. There we go. Okay. Something about me hitting enter I didn't like. Right. And so I actually got the table I needed. So apparently I've deleted all the NAs in it already. But it gave me a correlation table of those. But let's say you had some NA values. What you do is after the dataset name, so that whole big thing is the dataset, you type use equals, and the one I would suggest is pairwise.complete.ops. Okay, so pairwise complete observations. And then that will let you exclude the NAs. So if I had NAs, they would have popped up in here. Apparently I didn't, but that code is a useful one to know in case you want to exclude them. All right. Last but not least is this bonus question. So let's talk about this. This is subsetting a list. So everything we've worked with so far has been a matrix, a data frame, or a vector. So let's try running this as a list. So I'm going to run the code as specifically said. So I'm going to save this. So we're going to call this regression because that's what it does. And I'm going to use the lm function. Okay. And so I want to name this the data set I'm currently using. Let's just do lefties. See what they look like. Oops. Spelling. There we go. Spelling does count. And so this runs a linear model or regression where I am predicting someone's rating score with the number of times that it types. It switches fingers, so this is how it's typed. I'm going to predict whether or not they feel like the word is pleasant. And particular data set I'm going to use is the lefties data set. So I'm going to run that. Now it didn't give me anything. In general, if there's nothing down here at the bottom, that means that it saved it for you instead of just printing it out automatically. So over here under values, I have a list. So it is a list of everything in that regression. Look at all this crap that's in a regression. So it saves a ton of information for you. Okay. Now if I type in, give me a summary of that regression, it gives me what you'd normally expect to see, like it'll say if you're used to Spss or SPSS. It tells you the coefficients box, so it tells me that my finger switch variable does not actually predict the ratings. And then it gives you R squared down here, which is terrible, and then it gives you my F statistic, so how is that prediction better than 0? But that is most certainly not everything that's in here. So there's a ton of stuff saved, and this is why subsetting is so important, understanding how to get things out of lists and vectors and data frames that you wouldn't see with just a summary command. So I've already done this. I've saved the output of the regression by calling it regression. Now, I want the slope. And so if I look at everything that's in regression, so let's say give me a list of everything that's in the regression data set. The regression list. What we've got here is assign, call, coefficients, residuals, effects. Probably coefficients is where slope is going to be saved. So let's take regression and tell it to give me the coefficients. We're going to use the $sign here. Coefficients. And that gives me both of them. So that is a list, a vector, like a named vector within a list. Okay, so remember list can be a bunch of different vectors. And I've got two things, the intercept and the number of finger switches. Well, if I only want the slope, now the slope is the one labeled with the actual name of the variable and not intercept, what would I do? And so the answer to that is that within each little mini vector in a list, so if you think about a list as a compilation of a bunch of different vectors, we can still use the square brackets. Now it's really tempting to do this because that looks like it should work, but that doesn't work. because it seems like it should work that way, where it's like, okay, in the regression list, use this particular piece of the list and use that particular saved named thing. That doesn't work. So what you want to do is it's the second one. Oops, thank you, Studio, not what I wanted. There we go. If I'm looking at it here, it's intercept and then the variable I want. So I could just say 2 because it is 1 for intercept and 2 for finger switch. So that would tell me, hey, okay, I'll only give you one of them if you don't want both of them. Now that works great until you have a whole bunch of intercepts. So the other thing you could do is, let's say you want to just take the coefficients, you can call it its name as well. Okay. And so you can pull it out by name. So that is a named number, a name of that spot in the vector. But the hard thing to me about subsetting lists is remembering that once you've sort of used the $ operator once, you can't use it again. So you have to then say, within this mini piece of the list, I want number 2, or I want finger switch, or I want 2 through 8 if you have a whole bunch of coefficients. And so that is how you would subset in a list. And really the best way to learn that is to just practice. And so try different things and see what works. Okay. So all that together is the first assignment. So intro to R, so playing around with how do I work a lot of the functions in R.